Okay, so now that we know what a molecule is, let's look at what is holding those two elements together. Okay, and those are chemical bonds. And what a chemical bond is, it is this attraction between these atoms and makes them function as a single unit rather than two disparate units. And it's what is going to create that molecule, making it much more stable than either one was alone. And what determines that chemical bond are the electrons in that atom. And what is going to happen is either one atom is going to transfer electrons to the other atom, or they are going to share atoms between them. And so we have two major types of bonds. They are called ionic bonds and covalent bonds. Okay. So before I tell you about them, let me go back and revisit what an atom looks like. And this is a very old school diagram of an atom because now we know this isn't accurate. We now know that atoms are in this whole orbital cloud out there. But let's go old school when we thought they were like shells. Okay. And here we have the nucleus with the protons and the neutrons in the center. And then around it, we had shells. And in the first shell, there would be 2 electrons. That would be the maximum. And then the next shell would have a maximum of 8 electrons. And they would be spaced around. And this drawing is putting them in quadrants, 2 in each quadrant. But you could put 1 and space it. Instead of quadrants, you could space it every 8th going all the way around. And then the next shell would have 8 as well. And then there could be more and more shells depending on the electrons. Okay. And so that's the maximum number of electrons that each shell can hold. And you have to fill the shell closest to the nucleus full. And each atom loves it when the shell is full of electrons. It doesn't like having a partially filled shell. So if, for instance, if it only has 1 electron, it either wants to give up its electron or take another electron. If it has 7 electrons, it wants to take an electron. If it has 3 electrons, it wants to give an electron, so it only has 1 shell with 2. If it's carbon, it only has 6 electrons. So it would have a first shell with 2 and a second shell with 4. It's a long way from filling or donating. So this is the type of atom that's going to be looking to share. So looking at the shell, each shell has a higher energy level than the shell that is inside it. So this inner shell with only 2 electrons has the lowest energy one. And so the electrons are going to occupy the lowest energy level that they can. So once that inner shell is occupied, then they'll occupy the next one. And they're going to be most stable when the outermost shell is full. And when that outermost shell is full, then it's going to exist in nature without combining with any other atom. But if that outermost shell is not full, then it's going to look to combine with other atoms. And most atoms actually have a partially filled outer shell. And so they're only going to become stable if it can fill it. And so the way it's going to fill it is either donate electrons, steal electrons, or share electrons because it wants to fill its outer shell. Okay, so that brings us to the word ions. An ion is an atom that has either lost or gained 1 or more electrons. Okay, remember that nucleus has protons. If the number of electrons is the same as the number of protons, the protons are positively charged, the electrons are negatively charged. So this one right here with 6 protons and 6 electrons, this is neutral. So it's like Switzerland. It's happy. This ion with 5 protons and 6 electrons is negatively charged. Whereas this atom with 6 protons and 5 electrons is positively charged. Okay, so how can you become positively charged? Well, if you have one electron in your outer shell and you donate that electron, that would mean you would become a positively charged ion, which is what we call a cation. A negatively charged ion is what we call an anion. Personally, I like cats. So I remember positively charged are cations because I like cats. Negatively charged are anions. So that brings us to ionic bonds because ionic bonds are going to involve ions. So one atom is going to transfer electrons to another. So an atom that's receiving the electron is going to become a negatively charged ion or an anion. And the atom donating the electron becomes a positively charged ion or a cation. And so those two opposites are going to attract the cation and the anion fall in love. And ionic bonds are strong. And here's an example of an ionic bond. Sodium, which has an electron in its third shell, is going to lose it. Chloride, which has 7 electrons in its outer shell, is looking for one. So sodium is going to donate one. Chloride is going to gain one. So sodium is going to become a cation. Chloride is going to become an anion. Here is how to draw it in words if you don't want to, be drawing all the circles and stuff. And sodium chloride has an ionic bond and becomes the molecule sodium chloride, which is table salt, which is a very strong, we can sit table salt and it'll sit on the table and it'll be there for thousands of years. It will not break down because this ionic bond is very strong. So that's the first type of chemical bond. The second type of chemical bond is a covalent bond, as in they're going to be sharing. So once again, we have outer shells of the atom that are not full, so it's very unstable, okay? And so neither one of these atoms are going to donate. Neither one of these are going to steal. They've decided they're going to share one or more electrons. And in fact, most bonds in biological molecules are going to be covalent bonds. They're not as strong as ionic bonds, but they're much more common, okay? And by doing this sharing, both atoms will now have a full outer electron shell, okay? So they can share where there's just one bond where one electron from each atom will be shared with the other atom. So this is showing where each of these atoms had 7 electrons in this outer shell. So they are both sharing one atom. So now would have 8 in their outer shell. And then this is one where we have carbon with 4 atoms and hydrogens, each of them with 1 atom. So each hydrogen is sharing their atom and the carbon is sharing 4 atoms, one with each of the hydrogens. So they're sharing 1 atom with each other atoms. So now they are all very happy. But covalent bonds can also be sharing more than one bond. They can share a double bonds. An example of this is an oxygen bond. where oxygen, which has 6 electrons in its outer shell, is going to share 2 electrons with another oxygen bond. So those are covalent bonds. Not quite as strong, but much more common. And another example of a covalent bond would be when a hydrogen bond is going to share, well, excuse me, a hydrogen atom is going to share with another hydrogen atom. Each one of them has 1 electron to share. So I'll talk about that shortly. But first, let's look at these covalent bonds. We can divide them in 2 different types, whether they are polar or nonpolar. So nonpolar means the bonds are equally being shared. And so when they're equally being shared, that means there is no net negativity or net positivity. On the other hand, when we look at how hydrogen and oxygen are sharing their bond, what we find out is the 2 hydrogens are not going to be at opposite poles of the oxygen. They're going to be on the same sides. And so what we're going to find out is this side is going to have a little bit of positivity, just a tinge of positivity over there. And so this side of the oxygen is going to have just a tinge of negativity. And it's going to be enough so that when other water molecules come by, this positive side of another water molecule is going to bind to this negative side of this water molecule. So these polar covalent bonds are sharing their electrons unequal. So they're sharing, but it's not equal. It's like when mom tells the children, share, but one child takes advantage. And even though it cuts the cake piece in half, it's not an equal half, if you know what I mean. Okay, so let's look at the hydrogen bonds. In hydrogen bonds, the opposite partial charges are going to attract each other, and the atom with the positive charge is always a hydrogen, sorry. And that's what's making the hydrogen bonds positive. So we have a truckload of hydrogen bonds everywhere in our body. So this is a covalent bond, but it's a very weak covalent bond. So they're bonding and breaking, bonding and breaking, bonding and breaking, bonding and breaking, bonding and breaking. They are breaking almost as soon as they bond, but they bond long enough to form a molecule. Form a molecule to do its thing, then it breaks. Form a molecule, do its thing, break, 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 break. Okay. But the hydrogen bond is a very important covalent bond. Okay. And when we look at a water molecule, what we notice is any one water molecule can easily have like 3 different hydrogen bonds. And this is going to account for water's very unusual characteristics. And there's going to be a whole video just on water's characteristics. So make sure you watch that. Okay. So what I want you to do now is I want you to take a moment, look at these pictures and talk yourself through all the characteristics of bonds, and then come back. And when you come back, look at the next slide and figure it out. And do this quick think and figure out which one is which. And then I will see you for the next video. Thank you so much.